So in this video, I want to explain a new concept called hypothesis testing. And I want to start with a little story to get your intuitions kind of set. So suppose you have this friend, Sam. And let's say that Sam claims that of all the basketball games he's played, which is probably in the hundreds, he claims that his average score is 40 points. So that's really good, right? But Sam's a bit of a braggart and he's not very reliable. So you don't really believe him. You think really he's probably lying. That's what you think. And you actually think that his population average is probably less than 40. Okay. So, but you don't want to jump the gun. So you want some evidence for your thinking he's a liar, basically. And so you give him the benefit of the doubt initially. And so you assume that his average overall, his hundreds of games he's played is 40. But then you decide to go to 3 of his basketball games to see what his average is in those 3 games. So you go to the 3 games, and what you find is that the average in his 3 games is 6 points. So the sample mean that you get from those 3 games is 6 points. So you ask, do you believe, Sam, that his population mean is 40? Well, I think you would probably think he's lying, right? Because how could his population mean be 40 if he got an average of 6 points in the 3 games that you watched? I mean, that's super unlikely. The probability that he would get an average, a sample average of 6 points in those 3 games is really unlikely if his actual population average is 40. So you would be justified in calling him a liar and rejecting his claim that his population mean is 40. Okay. So let's consider another scenario though. So let's say though, instead of going to the 3 games that he gets an average of 6 points, let's say in those 3 games, you find that he gets an average of 38 points in those 3 games, that sample mean of 38. So in that case, you'd think, well, his population mean he claims is 40, and I see that he got in my sample 38. That's pretty close. I mean, we know that sample means aren't perfect estimates of population means. They're good estimates though. And if he got 38 in your sample, that's close enough. So in this case, we wouldn't have proved that his population mean is 40, but we would, say that's fine. You can keep claiming that. In a way, the statisticians would say this is that we would fail to reject his claim that mu equals 40. His population mean equals 40. Okay, but then you ask yourself, well, what point between our sample mean of 6 points where we rejected his claim and 38 points where we failed to reject his claim that the population mean is 40, where's the line between when we reject it and fail to reject it? Interestingly, we're going to find that this line's a bit of a moving target. It depends on how confident you want to be in your rejection. Like maybe you only want to be 90% sure when you reject his claim. Or maybe you want to be really certain when you reject his claim, like 99% sure. So that's going to be up to the researcher. Luckily, that's going to be given in the problem. Okay. So what we've done here is we've actually done a very lazy, intuitive hypothesis test where we basically had a claim about a population, namely that mu is equal to 40, the population mean is 40. And then we got some sample data and decided whether we were going to reject that claim or fail to reject it. So I hope this helps as we go forward and we learn some new vocabulary and we do more formal hypothesis tests. Thanks.